Hello students. So taking forward our lectures on combination of resistors. In the last class we studied potential method to solve combination of resistors. Today we will see one more type, that is infinite network. So these are also some of the kind of problems which you might get on combination of resistors. So like for example, there is a question given like this. This is a unit which is repeating infinitely, okay? And you have to find the equivalent resistance between A and B. So in this case, you don't have like how much you can go, extend, okay? Because it's extending till infinity. So follow the following steps. The first one, find the repeating unit. Look for the repeating unit. Like for example, in this question, this is the repeating unit, okay? This and this. Okay, this unit is repeating. Then again you have this and this. Then again you have this and this. Okay, so what becomes the repeating unit? This becomes the repeating unit. Okay, this portion. Now once you find the repeating unit, leaving one unit, one of the repeating unit, for the rest of the unit, assume a resistance. First assume some resistance of the circuit, okay? Let us say the total resistance of this circuit is X, for example, okay? You can take anything. X is the total resistance of the circuit. Now leaving one unit, you calculate the total resistance of the remaining unit, okay? What will be that? If for example, whatever is the network over here, if we consider the total resistance of this network is X, then leaving this part, that means from here, right? This much, this is the repeating unit, this is the remaining part. So if the total resistance is X, then what will be the resistance of this remaining unit? Obviously that will also be X, because if this is full X, then X plus infinity will be infinity only, right? So if you say that the resistance of the full circuit is X, then the remaining circuit's resistance will also be X, because it's an infinite network. Like 1000 plus 1 doesn't change, okay? So leaving one unit, find the resistance of the remaining unit. So that will also be X in this case, okay? And then complete the remaining circuit. Like if this is the repeating unit like here, and this whole resistance of this remaining circuit is X, then we can join this full resistance network like this and name it X, okay? And then the remaining circuit was R and R like this, okay? So now you can find the equivalent resistance between A and B easily, okay? So let's solve. I hope you got the steps. Firstly, consider any arbitrary resistance for the full network, X, Y, Z, whatever. Since R is already there, we are not assuming R, you can assume anything. Then find the repeating unit. Look for the repeating unit. Leaving one repeating unit, cut off the rest of the repeating units, and then find the resistance of the remaining infinite network. That will also be X, okay? Now then replace that infinite network with a resistance of value X, and then solve the remaining network. So that will give you the resistance of the circuit, okay? So here see, this is A, this is B, and this is our first unit which we've left, and the remaining of the circuit is having resistance X, which we considered. So that will be connected in parallel, okay? And what will be the resistance of this full remaining network? X, okay? Now can we solve this easily? Right, R and X are in parallel. So RP will be equals to R into X upon R plus X, right? This is the equivalent of these two. When you take the equivalent, then you have this R and RP like this. Now between A and B, R and RP are in series. So the R equivalent of the total network will be R plus Rp, that will be R plus Rx upon R plus X. Right? So what is the value of R equivalent? That means the total resistance of the network is X. We've assumed resistance of the full network to be X. So R equivalent is going to be X. That means X is equals to R plus Rx upon R plus X. Now solve this and you will get the value of X. X is what? Equivalent resistance between A and B. So cross multiplying, you get Rx plus X square is equals to R square plus Rx plus Rx. Okay? R square plus Rx plus Rx, like that. So 1 Rx gets cancelled. So x square minus Rx minus R square is equals to 0. So we have a quadratic equation. We need to solve for x. So you can consider A is equals to 1 over here, B is equals to minus R, and C is equals to minus R square. Right? So x is equals to plus minus minus B plus minus under root of B square minus 4AC by twice A. So that is equals to minus B. Minus of minus R, that is plus R, plus minus under root of B square is minus R square, that is R square, minus 4, A is 1, C is minus R square. So this will become plus R square. So upon 2, A is 1. So x is equals to R plus minus under root of R square plus 4R square is under root of 5R square by 2. Now x can have two values, R plus root 5R square and R minus root 5R square. Resistance values cannot be negative, right? R can never be negative. So we consider the positive value of x. So what is the positive value of x? X is equals to R plus under root of 5R square will be R root 5 upon 2. So value of x is, taking R common, 1 plus root 5 by 2. This is the value of the equivalent resistance between A and B. Right? Let's take the next question. The next question goes like this. This is one more infinite network given to you. Let's find its equivalent resistance between A and B. So the first step is assume any resistance of the network. Let us say the resistance of the network is Y. You can take anything, okay? Y. Now look for the repeating unit. So the repeating unit is, this is the repeating unit, right? What is it? This is repeating, right? Again, like this and this, then this, then this. So this is the repeating unit. So you look for the repeating unit and then segregate one unit from the rest of the unit. Then find the equivalent resistance of the remaining unit, that will also be Y. Then substitute for the remaining circuit. So our circuit leaving one unit will be, resistance of this full network will be Y. So let's replace it with Y. Okay. So now you can solve this. Here R and Y are in series and that network is in parallel with R. So we can write R equivalent is R in parallel with R plus Y. Okay. So R equivalent will be equals to 1 by R plus 1 by R plus Y. Right? Both are in parallel. So 1 by R plus 1 by R plus Y. What is R equivalent? Equals to Y. So Y is equals to see, first we write 1 by R equivalent is equals to R into R plus Y r plus y plus r. Okay, so 1 by r equivalent is equals to twice r plus y upon r square plus ry. That means r equivalent, taking the reverse, is r square plus ry upon twice r plus y. What is r equivalent? Equals to y. So y is equals to r square plus ry upon twice r plus y. Now you can solve easily. So 2ry plus y square is equals to r square plus ry. Okay, so taking everything that side, r square y square, we are solving for y, so y square, taking everything this side, 2ry minus ry will be plus ry minus r square is equals to 0. Okay, y square plus ry minus r square equals to 0. So a is equals to 1, b is equals to r, c is equals to minus r square. So again let's solve. Y is equals to minus b minus r plus minus under root of b square minus 4ac. So minus r square will give you plus r square. So divided by 2a. Again we are getting the same equation, right? So y is equals to minus r plus minus root 5r square by 2. Okay, so y can either be minus r plus under root of 5r square by 2, or y can be minus r minus under root of 5r square by 2. Okay, so which value you will take? Now you will say that both are negative. See, when you take root 5r square, it will be r root 5, right? You can write it as r root 5 minus r by 2. But this will be r minus r root 5 minus r by 2. So this is the full negative value. So this will not be considered, whereas this one will be considered. So what is the value of y? R root 5 minus r by 2. Okay. So with the help of this method, you can find equivalent resistance of any infinite network. Our next topic is going to be Wheatstone bridge. And in Wheatstone bridge, we will take some nice IIT numericals, and then we will see the concept. Thank you.